Good morning. I am Shreyansh, and I'll be speaking on the need for DPDK device driver framework restructuring. And always, sorry, I only have the Indian accent. I do not have the other option. Okay, Hemant was also supposed to be here, but he was unwell, and that is why he couldn't join us. I am part of NXP's digital networking software team. We are essentially working on leveraging the NXP's SoC over various open source data paths, for example, ODP, very recently DPDK. And the whole team, including me, we are pretty new to DPDK, so yeah, I mean, when I'm done with this slide, don't throw tomatoes on me. I am generally available on IRC nowadays, the DPDK hash, and you can always reach me at this email ID. This presentation is essentially broken down into two broad parts. The first one is a very short one where I'll just introduce what NXP SoCs are, and it will set the tune for the next part where the need for the DPDK restructuring and what solutions we have would be focused on. The other two are just customary, everyone does that. So, yes. So, as a part of the digital networking team, our aim is to get the DPDK, get the NXP SoC PMDs inbuilt into DPDK. So first part, of course, is getting the makefile, and luckily it's already upstream. So using an off-the-tree PMD, it's there in GitHub. I can compile the PMDs right now, that is the DPA2 architecture PMDs, and I can get working on NXP SoC if I use the appropriate SDKs. We still need some work done in those, and we need to break those into smaller sets. But these PMDs differ a lot from these generic PMDs which are available. For one, NXP SoC have inbuilt MACs, so they don't expose the MAC device per se directly on the PCI bus, and in fact not even on the platform bus. They have a lot of accelerators built in, and we need to use those accelerators when we are using the PMD. So our PMD code essentially builds on those accelerators. So we have the BMAN, the buffer manager, queue manager, CAM. I have some more, I have a slide down below which I'll talk about. So this is like more of a 10,000 kilometer view of what I'm talking right now. So we have the cores, there is the core area of the queue and the buffer managers, which in turn talks to the accelerator, and the WRIOP, which is the wire-end IO processor. So this is the like big view, and nobody needs to go into detail, but it's essentially the Core IQ brand, which in Freescale, or which is now in NXP, sells. So this is the recent most version, that is called LS2088, and what is of interest in this is this particular block. So essentially this is a fully virtualized data path stack which the applications can use, and there is a proper zero copy addressing, user space virtual addressing as well. It is serviced by a management complex. I'll be very quick with this. It's serviced by a management complex, which is essentially is a glue code between all the accelerators and how the user space use those accelerators. The WRIOP, which is essentially the person which takes the packet or puts the packet back in the queues. And this is, it is intelligent enough to do some sort of distribution and queuing, and has an L2 switching built. There are other blocks like the data compression engine, that is DC, the PME or packet matching engine, and the ACC. The heart is the buffer manager. So I'll just correct, I think it was stated that nobody is using the external mempool. We are using the external mempool of the offload. It's just that the PMD is not upstream. That's the only difference. So yeah, but it's upstream. It's there on GitHub for anyone to have a look at. Yeah, so QMan is the queue manager and the buffer manager. These are like hardware, queue and the buffers. We pin all the buffers in the hardware where the application and the blocks can access those buffers without any locks. So this is where the accelerator blocks works here. Again, the same view is in just a different angle. So what is of interest here are, if you notice, the DPBP and DPNI. So the DP architecture per se exposes a lot of objects. There are DP star objects, I should say, the data path star objects. Two of them, that is data path buffer pool and data path network interface, are of interest because this person exposes the queues which can be directly accessed during the applications, and this person is the offload pool which we are talking about. So what's different is that SoC by definition is no standardization. They're not count for 7. When I talk about SoC, there is no standardization. So for example, NXP itself has two different SoCs. One is platform bus supporting, so it has all the platform bus compliant features, whereas another is a proprietary bus. So there's one other by Cavium, which is a PCI based bus. So even assuming that any SoC would be using a standard bus which can be used to detect devices is not the correct assumption as such. So this is where the problem starts. Okay, this is where the second part of the presentation is. DPDK has always been inherently PCI specific. I mean, it was built around Intel's devices, it still remains PCI specific. If I show you some examples, the ETH and the ETH driver, the Ethernet device and the driver, they embed the PCI device and driver respectively. So does that mean an Ethernet device has to be a PCI device? So, but that's not right. I mean, I have an example here, which is Ethernet device is not a PCI device. Secondly, EAL initialization assumes that all the devices would be available on the sysfs and which would be accessible using the BDF, PCI BDF. That's again not true. I mean, my device is not accessible. Even if I plug the PMD, I cannot get the devices up in the PCI driver device list or any drive devices for that matter. So it assumes that all devices are discoverable through sysfs. I can go on and plug more buses. For example, I can say, let's have RTE underscore platform underscore device in ETH device, RTE underscore platform underscore driver in ETH driver, but that's not the right way. I mean, I am breaking the ABI every time I do that. And same logic applies for the scan as well. So there has been some work done on this. I mean, Keith would recognize this. This was a presentation which Keith gave all the way back in DPDK San Francisco Summit 2015. That set the tone. I mean, there is an SoC PMD which was proposed. It was parallel to the PCI. What this presentation was talking about is more of having a clear bifurcation of a PCI world and a non-PCI world. Right? So again, SoC as such, the word is a debatable thing. Should I call it SoC? Should I call it NXP proprietary bus? Should I call it platform bus? That's a debatable thing. But again, this set the tone, stating that there is a need for a SoC PMD per se, and which will require some changes in the EL also. Again, there was work done by Jan in January. There was a patch set released by Jan listing here, and that patch set introduced the RTE SoC driver and RTE SoC device, which was parallel to the PCI device and driver objects. So it did the two primary work, that is introducing these two objects and introducing the scan for these objects, scan for the SoC devices. But again, that patch set was focused on platform bus. So it was assuming that whatever SoC was connected was exposing all its devices on the platform bus, and from that it could find all the devices, plug it into the device driver list, perform the probe on them, attach it to the PMDs. After May, I mean, almost like 4 months, there was no action and no work being done on those patches. V4 was recently released by me, and the only primary difference that has been done is I made those functions of platform search and match as optional. They're more like default handlers which are available for anyone to use, but a PMD can be defined which can attach its own scan and match functions. Once it scans, it can create its own device driver list. For each device that is observed, a match can be called and assigned to the driver. This is very similar to the PCI structure. So this was the first step, the first block is the first step towards allowing non-PCI devices. But again, as I said, it's not the right step, it's not the end goal. There has to be a better way wherein I do not come up again and again to add new RT underscore XXX underscore devices. So whatever I have said, I've just explained them again in a little descriptive way here. There has been multiple series which are either in the upstream or still working in the upstream to move towards this problem or solve this problem. There was a series by David Martin from 6Wind. Again in January it was released, and what it did was it fixed a specific problem. So if you notice on your left side, RT-PCI driver was inheriting from RT driver, but RT-PCI device was like a class in itself. So this is a broken structure, there is no symmetry in this. What this patch set did was, it introduced a RT device, an RT device driver structure, and every device and drivers were getting inherited from these classes. It still had the Ethernet driver issue, so there are two issues here, the very tiny ones. I mean, it's not RTeth driver, it should be RTeth drive actually, in parallel to R3 dev. These two still embed the PCI devices. So this problem still remains, it still has to be delinked here. The SoC patch set, which is still floating, what it does is, it introduces two new device layers parallel to the PCI. I have written XXX here because there has been some debate with respect to what is the right name. Whether it is SoC we should name it, or whether it is platform we should name it. I mean, objections have been raised on either, but no consensus has been reached yet. The patch set actually does RT-SoC driver and RT-SoC device. So it just introduces a parallel layer to PCI, VDEV, RT, and if we go along, probably we'll have more such things coming below this as and when required. The next step would be, this is the RT patch set, of course, and we have, I have not shown the SoC device and driver lists here, just for simplicity's sake, but an open question remains whether we should have separate lists for all the devices or common lists for all the devices. I mean, there are pros and cons to both. If I have a common list, I'll have to have some if cases within the code stating whether it's a PCI device, whether it's a SoC device, whether it's a VDEV device. If I have separate lists, it becomes a little problematic to manage everything. But again, it's an open question. The SoC patch set introduces a separate linked list. It does not merge those lists. The next step being, of course, getting the name correct and doing this assignment. So these are like two small steps. But eventually, it is not the right, I won't say it's right, I mean, it's not the eventual aim. The aim should be, in my opinion, something which Linux device driver model does. So there has to be a bus, there has to be devices attached to the bus, there has to be drivers servicing the devices which are attached to the bus. Buses should profile devices, buses should match the devices and assign to the drivers, drivers should take control of the devices. So this is a standard model which Linux kernel does, and this is where we should be heading if we do not want to break the API every time by introducing RTXXX device, RTXXX drivers. So this still needs, this is again, I should say this was proposed, or it was in discussion with Thomas that this idea came up. There was a patch by Declan, not patch, there was a proposal by Declan also somewhere in August, which did similar, but it actually was much more elaborate. That proposal was like, break it into bus data, break this into driver data, break this into device data. But again, I have taken a middle path. This is not a proposal, this is more like a thought process. To break everything into a bus device driver model, a lot of things will have to be done in the ABI layer, in the EL layer as such. What I think should be that we should have a RTI bus. EL should be working on the bus to probe the devices. PMDs are named as drivers, but I do not know whether they can take the bus responsibility, or maybe we'll have a new semantic for bus. There should be a new bus registration function. Buses should be registered. Buses type should be specified. Drivers should plug themselves to a bus. Devices should register themselves for a bus. Buses should probe the devices. Buses should match and assign it accordingly towards the lower hierarchy. That way, whenever a new vendor, for example NXP, comes in, it wouldn't have to struggle with getting its PMD in just because of the lack of scanning the bus, which is a proprietary bus. So yeah, this is the overall model that I'm still working on it here. Oh, sorry. Okay. So overall, if I just collect everything and state, there's a two-step process to this. One is a short-term goal of getting non-PCI devices in the EL. The second goal is overhauling the complete EL. So the second goal is not a simple step, because I'm pretty sure it is going to impact performance some way or the other. I'm going to have hooks for every action, and these hooks are going to cost something or the other. But again, there are ways to do away with those. Eventually, it's more of getting an in principle agreement that the problem exists and it needs to be solved. So, as I said, it's a step-by-step process. First, we bring in the pluggable scan bay. We have non-PCI devices, and then we go ahead and change the final architecture. So that was one part of what stops NXP's PMD from embedding into EL. This part, I mean, whatever is written there is not really stopping, but this is another improvement area. NXP PMD is using the external offload. The problem, there is no clear semantic for an application to know whether it is working on an offloaded pool or not. Packet offloads are good. Non-packet offloads are not good. I start using a mempool which is getting offloaded, and I use that mempool for my own internal buffers or metadata. It's going to impact performance. So ideally, the API layer, the topmost API layer should be very clear. RT packet embuff create should only be used for packets. RT mempool create should only be used for non-packets. So that segregation is there, it's just not documented well. Even now, with a couple of applications, in fact, Olivier, I was talking to Olivier and he also agreed that there are still applications which are using RT mempool create for packet buffers. Application means examples, so it's not the right way. Ideally, we should be moving towards a uniform method where applications know which pools they are talking about and they use those specific APIs. Point one. Point two. We came across a situation where an application which we were running on the host, when we moved it to a virtual machine environment, it broke. It broke because offload available on a host does not mean offload available on a virtual machine environment. Right? So obviously we stuck in a question arises, what should happen in such cases where an application is using an offload pool and that application is moved to a non-offloaded environment? Should it fall back? Should it have a error returned back? Or should we have an option on command line that, all right, let's change the pool at runtime, or should it be a built-in system? Something has to be done about that. So there are some patches which are again floated in the mailing list which propose something on this as well. So these are the two possible cases that we had problems with. Overall, if I talk about what is the status check of I as an XP person getting PMDs in there, I can compile my PMDs right now. Offload framework is working thanks to David Hunt. Non-PCI device support, it's multiple patches are there. The patches have been floating since January. Multiple people have worked on it, but there's not much involved. I think only Jan and I are actually right now working on those patches. Yeah, so nobody else is actually able to review those. There's a phased approach we should follow. First, getting the patch set as either as an experimental or just getting it towards the next tree, and then the complete overhaul has to be done. And then, of course, there's an event-driven model which, so NXP's hardware is built on that event-driven model. So that is where we extract the best performance. The patch set as RFC has already been posted by Cavium, and we need to work on it. We need to get it finalized. I mean, at least come in principle agreement to the overall patch set, so that we can push our support features on that as well. Yeah, I mean, that's a very short presentation. Thank you. Anything? Yes, please.
So in fact, the question is as simple for you and for Steve. I mean, will this model helps for the VM bus support that is used by Hyper-V?
Sorry, I cannot hear you. I'm very sorry.
So let me repeat the question. I was asking at the same time for you and for Steve if this model will help for the VM bus, which is for Hyper-V.
Not really, because VM bus is very much an analog of PCI, so you have SysFS, you have the same. The SoCs have a different problem where the devices don't live in the same universe, or switched out kind of devices have the same problem as well. The other issue that we have in the DPDK is we're kind of exposing our internal laundry a lot. We don't have clean APIs for the application to query system state. and because of that, they're dumpster diving into device infrastructure, data structures, and we're exposing that. I mean, ideally, if we were built as a clean package, there would not be any RTE ETH device visible to the application at all. There would be no RTE PCI visible to the application, and the application would only query through known APIs, so different vendors could change the bus layout, and we could add and delete fields in versions of DPDK, and we would not break applications, and that's not the case today.
So in fact, yesterday when Stephen was presenting, I heard at the last that you were saying that it's PCI committed, and that is where I hit that. Probably that is why I didn't hit this issue. Anybody else? Jack.
Hello everybody, my name is Jan Victorian and I'm the original author of those patches, and you could see me last year here when we pushed the ARM basic stuff into the DPDK. And I would like to first of all thank to Shrange to take over my patch, because my time to DPDK is limited those days. And I've got maybe a comment. We were discussing this on IRC a bit, and that's the principle of scanning and matching the devices. And I personally don't like very much the approach to move the bus-specific logic into PMDs. I don't know if anybody has any opinions about this. I don't like this very much because it brings a lot of questions how to solve many problems. Like anybody can bring easily a new bus, that's a good feature, but it makes all the infrastructure quite unmaintainable, let's say, maybe. So this is my point to this. However, Shrange tried to explain that this SOC area is very heterogeneous, and there is no standard. It's difficult to find some base where to start from, and that's why I started with the platform devices, or that's the term you can find in the Linux kernel. And my approach was to base on this and stay as much close as possible to this approach. But I like the way that we can customize the scanning and matching for certain devices. But in the area of these platform or very related devices, I have no idea about more implementations. And the thing we made this year was that the DPDK is now much less dependent on PCI, and anybody can introduce another bus infrastructure into the system. The DPA2 that NXP is using is, from my point of view, another bus system that should have a representation in EAL probably, and it should be a separate thing. And any other vendor that comes with a bus system can add such a bus system next to those systems, and it's okay. And I think we should support this approach. So we can probably introduce some custom scan and match functions, and temporarily have some drivers until we find out the right way how to do it. But I'm afraid to freeze this state in this, which would introduce some ABI issues into the future. I was talking quite long. I don't know if you catch it all.
Yeah. Okay. See, you hit on the right point. SOCs do not have standardization. There is no way we can have a generic approach to everything. So the primary reason that we have a pluggable architecture is so as to allow more non-known areas to plug it into a central area. EL needs to be that pluggable. Right now it's not. If I assume that, let's say this is only a platform library we should have, so I have one new method, that is libt_el, libt_platform. This is what probably that day we also were thinking. So again, there are many ways to do it. I'm not personally in favor of this library idea, but if we can have some consensus going on those patch sets, we can at least think about a common answer. In my opinion, EL needs to be pluggable. Pluggable in terms that a new PMD, which is unknown, may or may not be upstream right now, can come in easily, push their code back into the DPDK, and we can have a better way. Slowly, over a period of a year or so, we'll come to know what are the use cases that they are supporting. So if the use cases lean towards platform, let's have it as a separate library altogether, so that it's optimized and it's separate, it's maintainable. Many ways. It's just a matter of setting in principle agreement in those ways. Thank you. Oh, sorry. Hi, Chris.
Is it what? Yeah. I know that Intel is working on FPGAs, so I assume there will be some connection here. There are processor interconnect that may be coherent, like for IBM this is CAPI, and there is also OmniPath for Intel for connecting stuff. So is it, I don't see what you're describing as a specific SoC problem. That's more generally something that devices or CPUs are getting closer and closer because the need of performance. So is there any person from Intel or from FPGA companies that could comment on those, the need of special non-PCI devices?
Is there any from Intel who can comment on this?
Just on that, the way I looked at that, and it was kind of in the proposal I replied to the email list, that we would have this a memory mapped, what you're calling so the bus types, you'd have a memory map bus type. It's generic bus type because, so if it's an OmniPath or another specific type of interface, it's still, eventually it's going to be mapped into the memory space of the processor, the OS. Then if the EL level is managing just buses, if you have a memory map device it's a device that's on a memory map bus, you can the POMO driver itself can give the specifics of where it needs to look, how it needs to manage that, but the EAL could be then completely abstracted from any device-specific information. I think from my working with SoCs in the past, I don't see anything that is particular to bus management that needs to be in the EAL. So even say for the PCI devices, really what's PCI specific is going to look at sysSIFs, understanding the BDF lists, and then it's just mapping the memory space in. It's this. I think for all of these all of our devices, it's the same problem that needs to be solved. If we have that's kind of what I was trying to propose is in my reply to that mailing list, was that you have just a very low level bus management, and if you need to, if there is some sort of new bus that comes along in the future that needs special support, that would have to be upstreamed into the DPDK. It wouldn't be something that would be pluggable. But if you then have all devices are based on RTE device structure, all drivers are based on RTE driver structure, then the whole EAL can be completely abstracted away from any particular device, and it would open the market for maybe further down the line when people are developing custom FPGA solutions, that they can hot plug their own driver and their own device type into DPDK. It will still interact correctly as we expect with the EAL layer, and it would allow long-term, I think, one of the more flexible solutions. It probably needs that that's just kind of a very high level idea that I think probably needs a bit more elaboration, but I think it should be possible. I don't see anything, I haven't seen anything in any SOC that would say you need to have some special logic at the EAL level to manage how that interacts with DPDK.
Okay. Oh, okay. I'm done if there's no other question.
May I comment?
Sorry,
in my opinion, it's not a so difficult question. Actually, we need 4 things. First, we want to be able to scan a bus. Then you want to send a notification event to the application that you found some devices.
Yes.
Then your bus must be able to match the devices.
Yeah.
And at the end, you just run the initialization procedure. Then we are talking about non-PCI buses. I would like to talk about just a bus object, and the PCI case should plug in this infrastructure.
Right.
I think we must be able to plug some common buses like PCI in this infrastructure, and we must be able to plug some drivers which have their own bus also. You see?
Yes. So I
That's maybe your case. You embed your own bus in your driver.
Absolutely.
But in some cases, we want to have some more generic buses like PCI or virtual driver.
So we can have those generic buses as part of the EL. All the other non-generic buses, they come in as a pluggable modules or pluggable code itself. That makes sense?
Okay.
Thank you so much.
Thank you, Shreyas.
Thank you.